We're differentiating using chain rule. So let's take the derivative of the outside, the big picture. So bring this 2 down to the front, right? And you will have 2 times, keep that inside part exactly the same for right now. We're not doing the inside part right now. We're doing the outside. And the old exponent goes down to 1, right? Now remember, we need to multiply this by the derivative of the inside part. So this ddx notation is just me communicating with you that I am taking the derivative of the inside part. Now what's the inside part? This 2x squared plus 3. So I'm about to take the derivative of that orange binomial, okay? So let's bring this down for right now. But you know what? Before I bring it down, I may just distribute this too, because taking exponent of 1 isn't really anything. So I can distribute this 2 and write it as 2x squared plus, what's that going to be? 6, right? And now the derivative of the inside is about to pop out, okay? I'm multiplying this by derivative of x squared is 2x, right? And derivative of 3 is just 0, so this is it. So I guess we can stop there, but if I want to distribute it or multiply it and write it in a standard form, I can say that my final answer is 4x to the third power plus 12x. Okay, so that can be the final answer here. Okay, let me do one more down here. Ooh, a little bit bigger. And this one I am not going to multiply it out because look at the power, it's to the 10th power. But let's do the chain rule. First, take the derivative of the big picture, the outside. What's the outside exponent? 10, right? We're going to have to bring this down and multiply by this 6, right? So what's going to be the new coefficient this time? We're going to have 60. But don't change anything inside the parenthesis. We're dealing with outside first. We're not doing inside just yet. See, everything stays the same. What should be the new exponent now? 9, right? Now, if you stop there, then you're only halfway done, okay? Now, we need to multiply this by the derivative of, that's what I'm using this ddx symbol for, the inside part. And you notice the inside part is this trinomial. So say that you're taking the derivative of x cubed minus 5x plus 1. So in my next line, I'm going to copy down the first part exactly the same. I'm not really doing anything to this first part. I'm about to go handle that orange part, okay? All right, let's do this multiplication, this derivative. X cubed will give us 3x squared, right? Derivative of negative 5x is negative 5. And derivative of 1 is just 0, so I don't have to write that. So this is my final answer, and I don't really have to put this multiplication dot in between them, and just can say this is my final answer. Now look though, you know, if you want to write this like in the kind of like good order, you may want to consider writing this in a monomial times. You see 60 is just a monomial, right? I mean, they're all monomial, I'm sorry. But like the shortest one, this is just a number times, you notice this one has like 2 terms inside, this one right here. So I may write this next. And then I will write this trinomial with the squaring like last. But really the order doesn't matter when you multiply things. So both are perfectly fine answers. And I was just like, why did I do that? I would probably just stop right there. But these were 2 examples of chain rule problems on page 48.